That is the end of Part B. Now turn over and look at Part C. Part C, questions 31 to 42. In this part of the test, you'll hear two different extracts. In each extract, you'll hear health professionals talking about aspects of their work. For questions 31 to 42, choose the answer A, B, or C, which fits best according to what you hear. Now look at Extract 1. Extract 1, questions 31 to 36. You hear an interview with Dr. Christine Erickson, who's talking about her research supporting non-fasting lipid blood tests for cholesterol. You now have 90 seconds to read questions 31 to 36. Hello and welcome to Health Research Roundup. For decades, people have been asked to fast before they have blood tests to check cholesterol levels. However, a new research report from an international group of experts suggests that this is not necessary. To discuss this research, my guest today is Christine Erickson from Copenhagen University Hospital, who was a lead author of the study. Christine, welcome.
Thank you very much.
So why did we ever ask people to fast for blood lipids, for your blood fats?
Well, if you ask me, I don't really know, except for that's what we've been doing for so many years. I really tried to read the literature and find some very scientific evidence supporting that it is superior to just taking a random non-fasting blood sample as we do now. And I had problems finding the evidence. There's a lot of arguments people put forward for why you should use fasting versus non-fasting, but really solid evidence that is better, I can't find it.
So was this a tradition rather than science?
I think so, yes. I mean, you can ask me why did it start? I think that some of the early studies, the original publications way back, said that they used fasting samples and therefore everybody thought you had to do that without really thinking why. But those early researchers may have had good reason to do it that way, but there's nothing I've seen that said it had to be done that way. And there's all this evidence now from Canada and the US, 2 excellent studies, one in children and one in adults. And then we have a lot of studies from Copenhagen, and they all show that when you just look at people that eat and drink whatever they usually do, and you take a lipid panel, cholesterol, triglycerides, a very common fat in the blood, then they don't really change very much in response to when you have been eating.
So there is a difference?
Yeah, the difference is in millimoles per litre. So it goes up by about 0.3 millimoles per litre. However, in clinical practice, when you look at triglycerides, you're interested in whether it increases 1 or 2 millimoles, not 0.3 millimoles. So that's what's clinically relevant.
And even with a bad form of cholesterol, that's not going to make the difference between whether or not they put you on medication?
Yeah, that's right. We provide data in this report where we did direct measurement and after fasting and in about 6,000 people, and the correlation between the two methods was, I can't see the difference. It looks exactly the same.
So you moved over in Denmark to this official recommendation about 7 years ago. So what's happened since then? Have there been any issues because of undiagnosed cholesterol levels?
No, everybody was happy right away. Even the laboratories that didn't change right away, they were pushed by patients because there were reports in the media telling them that at Copenhagen University Hospital we're doing non-fasting, so everyone wanted to do it. And I can say today, patients, clinicians, laboratories, everyone's happy. Everyone likes it because it's so much simpler.
And patients like it because they can go when it suits them to the pathologist, so they're more likely to turn up for their blood tests?
Yes, of course. I don't have fantastic good numbers for you, but certainly hear from so many colleagues that people don't go to have their lipid test because it's so complicated to fast. And then they have to go to work, to have an important meeting, and they can't do this in the morning. But now, doing a random non-fasting, you can come whenever it suits you.
And very briefly, is there any circumstance where you should have a fasting blood fat level done?
Well, this recommendation, it's 21 world experts, many from Europe, the US, and one from Australia also. And of course, when you have so many experts, there's always someone that thinks there's certain situations. We list a few where you can do. For example, for patients with diabetes, the fasting requirements might be an important safety issue because of problems with hypertension.
Now turn over and look at Extract 2. Extract 2, questions 37 to 42. You hear a presentation in which a researcher called Dr. Milan Petricevic is talking about the relationship between new technology and medicine in the future. You now have 90 seconds to read questions 37 to 42. Hi, I'm Dr. Milan Petricevic, and today I'd like to talk about the future of medicine, particularly in relation to the current technological revolution. To many of us, it seems inevitable that medical robots, automation, and artificial intelligence will replace many jobs in healthcare. Surgical robots are becoming increasingly more precise, and right now, man-sized robots can lift and move patients and transport them throughout a hospital. Silicon Valley investor Vinod Khosla once said technology would replace 80% of doctors because machines will be more accurate, objective, and cheaper than the average doctor. He added that eventually we won't need doctors at all. However, I disagree. Instead, I think technology in some specialties will finally allow doctors to focus on what makes them good physicians, treating patients and innovating, while automation does the repetitive part of the work. So let's look at some examples of how different areas of medicine will benefit from current technological advances. Take general practitioners as an example. Many doctors choose this specialty today because they have a chance to make a long-term impact on someone's life. And it's true that GPs enjoy tremendous trust from their patients. But seeing someone only when they are sick makes it hard to prevent disease and ensure someone's long-term well-being. It's even harder to do this when waiting rooms are overflowing and you only have 15 minutes to diagnose the illness, design a therapy, and offer health advice. In the future, wearable sensors and devices that stream data to a doctor's smartphone will notify them whenever vital signs are acting up and provide them with all the data they need wherever they are. These devices will also ensure doctors only treat patients who really need professional care, making it possible to offer simple treatment advice remotely. In turn, this will increase the time GPs have to treat and advise each patient, building trust and ensuring patients act on a doctor's advice. What's more, smart algorithms will allow GPs to tap expert advice on their patients' conditions and act as a gatekeeper, connecting patients to other specialties. And these are just a few examples. So what about radiology? Well, already IBM's Medical Sieve shows how artificial intelligence algorithms can scan hundreds of radiology images in seconds, doing the repetitive job of finding malignant or out-of-place phenomenon that currently radiologists have to do daily. This technology won't replace this important specialty. Instead, radiologists will have time to supervise how the algorithm is doing, or to research and innovate, making the technology behind these devices even better. Their time will be much more productive rather than spent checking hundreds of x-rays a day. Ophthalmology will bring science fiction technologies to patients in the near future. Retinal implants might give vision back to those who have lost it, or even give humans supervision, augmenting what we can already do. In sports medicine and rehabilitation, the first forms of activity records from tech like Fitbits all focused on people who exercised regularly, but only provided basic insight into how they were performing. Now, a new generation of devices tailored to professional athletes is hitting the market, with apps providing detailed insights into movement patterns and force output in any movement. Sports medicine physicians will have concrete data to measure how athletes are improving. By the time these reach the mainstream public, sophisticated algorithms will be ready to analyze data from these devices and provide personalized suggestions to improve performance and to speed up recovery. Similarly, video consoles from Xbox to Microsoft Kinect will offer a way of monitoring how a patient is doing from a distance by seeing their progress liquidly on a screen. In oncology, this specialty will pave the way for personalized medicine. Even now, oncologists customize therapies to a patient's genetic background and their tumor's molecular makeup. Cheaper genome sequencing and measuring blood biomarkers are speeding up this process, with companies like Grail working on fluid biopsies which could filter tumor cells from blood samples. Tumors could soon be diagnosed earlier and analyzed without costly surgery. What's more, artificial intelligence could soon be used to help oncologists understand and even cure cancer. Already, IBM Watson obtains all the relevant information from millions of studies about a patient's case and makes suggestions for treatment plans most likely to work. In the meantime, patients are better informed about the disease thanks to social media communities of fellow patients. These signs all point to a bright future for oncology in partnership with new tech innovations. So what does this all point to? Well, my conclusion would be that, all in all, many jobs will be taken over by robots and automation in the coming years, but at the same time, amazing opportunities will also emerge, especially in medicine. These will require physicians to acquire new skills and improve their existing ones. In my opinion, the majority of specialties will have more time for patients and better insight into disease. That is